So thank you so much for joining us today, Robert, on the Open Source Observability podcast. And I'd like to start by asking you a bit about your background as an engineer, and if you could tell our audience what you do to support Valkey now as a senior open source developer advocate.
Hey, hi Alex. Thank you so much. My name is Roberto Luna Rojas, and I usually go by Robert. And I'm a software engineer based out of North Carolina in the USA. And I've been doing software for about 20 plus years professionally, over 28 now, maybe since I started. And a lot of focus on architecture and databases, specifically in data modeling. And that's where I got really excited about databases, more specifically in memory. And my work as a DA or developer advocate is to create awareness about Valkey, which is an in-memory database or data store to write content, speak on conferences, and collaborating with the larger open source community. And thank you so much for having me.
I'm really excited to chat today and help our audience learn a little bit more about databases and use cases for observability. So for anyone that isn't familiar with Valkey, can you explain a little bit about what it is?
Absolutely. Valkey is an open source, high performance key value data store that is designed around simplicity and speed. Think of it as a super fast database that lives entirely in memory, which makes it incredibly quick to store and retrieve data. So it's built for situations where you need lightning fast responses. And we're talking about microsecond level performance. Actually, it's usually about 300 microseconds or so in most cases.
Really, really fast. Cool. And so could you also describe a little bit about the relationship between Valkey and Redis and the connection between those two tools?
Absolutely. Yeah, Redis is the original project. It was created back in 2009 by an Italian programmer named Salvatore Sanfilippo. So he used to be kind of the leader of the project, and then a company called Redis acquired the trademark and the software. So back in March of 2024, they decided to change the license from BSD to source available. So some of the developers who were contributors to the open source project decided to essentially take a copy, fork Redis, and create Valkey under the Linux Foundation. So that makes sure, or making sure that it's an open source whatever project is staying vendor neutral.
Yeah, and it's really great that that resource got to stay open source so people can continue to use it. And for people that might be tech adjacent or newer to FOSS, the licensing can get a little confusing. So could you describe the difference between a BSD license versus, I might even mix this up, the AGPL v3 license, which is, I think, what Redis is using now.
Correct. Yeah, so it's a great question. So let me break down in simple terms. So BSD, it stands for Berkeley Software Distribution, which is a license that it's very permissive, essentially saying that, hey, here's some free code, go and use it, change it, do whatever you want, as long as you keep the copyright on it, right? So it's designed for maximum flexibility and adoption. The GNU AGPL, or Federal General Public License v3, on the other hand, is what we call copyleft, or the copyleft license. It's a little bit more restrictive in the sense that you can take that code and you can make changes to it, but if you do that, then you have to bring those changes back, right? So it's essentially, it seems like a little bit of a SaaS loophole where it's designed to ensure that improvements benefit the entire community. For Valkey specifically, the BSD license was chosen because that was the original one and ensures maximum freedom and compatibility.
Yeah, so it sounds like with the licensing changes that have happened to Redis, basically Valkey is here to make sure that it stays open source and there aren't those kind of SaaS loopholes. People can use it and distribute it however they see fit. And work on it as a community, which is really exciting. And I wanted to kind of dive into how a key value data store, as you described, Valkey is. It would differ. How does it differ from a relational database like Postgres or MySQL?
Yeah, that's a fundamental question that really goes back to my roots of designing databases and doing data modeling, right? So essentially, relational databases like Postgres or MySQL are built around the concept of tables and structure, rows, columns, right? So there's this referential integrity that you try to reduce the amount of copies of the data. And this is a design back from the 70s where disk was expensive. right?
Mhm.
So that means that you wanted to keep as references or by using directionally items that will tie the data together. So this is great, and it's super flexible with the SQL query language. You can join all these pieces together and represent the data in the way that you need it. But that comes with slowness, right? So you need to understand the queries and then go back to this, fetch the data from it, and then bring it back to represent to the application. On the other hand, key value data stores like Valkey are completely different, right? So essentially, you have a giant hash table or dictionary where you have a key and then a value that is what you need, right? So this is a different mindset where you use these databases where you already know what to look for and what to expect. Of course, uh, the value that Valkey brings is that it supports multiple different uh, data types as the values. So it could be also complex, right? It could be collections or things that are meant to give you ultra fast performance. So from my experience in the creating applications doing this, you can really change the way that applications uh, give you responses, right? Especially given on time and the scale that you can get. Because at the end of the day, when you're relational databases, you can just have as many requests as the disk can give you, and then you can just have copies of it. With a key value database, you can shard it. That means you can partition it and scale essentially virtually unlimited horizontally. So, for
Interesting.
example, in one of the applications that I did, it went down from 400 milliseconds to under 50 milliseconds in response times.
Yeah, so a huge difference in speed. I wanted to ask, since you said part of the relational databases is when disk storage used to be a lot more expensive, are key-value data stores more possible now because storage is a lot cheaper?
Correct. Yeah.
Okay.
So it's you can still store a lot of data on a disk-based database, right? Um, you can always do partitioning logically. So you can say, okay, I'm going to have like hundreds of tables or thousands of tables for the historical values, right? And that's where data warehouses and data lakes come in. It's more about the way that you interact with your database is like that's kind of the fundamental change. Mainly going like when you think about a database like Valkey is when you can really need that speed, right? Like you are going to have faster responses, better user experience, and reducing resources as well.
Interesting. Yeah. So really, really fast and also uses less resources. And it's possible now because of changes we've seen in hardware. Since I think you said Postgres and the other stuff goes all the way back to the 70s. So it's interesting to see what new technologies are possible because of how things have evolved. And I wanted to ask, what is a really good use case for something like Valkey, like for a key data store?
Yeah, perfect. Well, the sweet spot for key value stores is when you need blazing fast speed and you know what you're looking for. Right? Essentially, caching a web page, for example, or storing the user session, like when you have a shopping cart, leaderboards in gaming, or powering message queues as well. And lately, I've seen a lot more use cases for AI ML as well, where you use it as a feature store in order to train a model or do a real-time inferencing. And now, in the last couple of years, as a vector database as well.
Interesting. So yeah, now it's also kind of supporting innovation in AI also, which is it's something cool that open source is able to facilitate. And since you mentioned vector, I wanted to talk about I saw that the summer Valkey released something called Valkey Search, which is sort of similar in capabilities to vector search. So for new engineers that might not have used these tools before, can you describe what vector is and how Valkey Search can help improve their work?
Yeah, excellent. So first, let's take a step back and to understand what a vector is, right? So vector is a numerical representation of the data. So what that means that you have um, like an image or audio or video or text, and like if you have a PDF, right? It's just words, right? Random characters all over the place that don't follow a certain structure. So you need to take that unstructured data and convert it to numerical values. So that's what the vector is. Like essentially, you are able to provide a set of the dimensions, right? You can say, for example, 384 or even 1,500 different dimensions on what the data is. It has a numerical value representation. So you take that, and what vector search allows you to do is to try to find similar patterns. For example, in the case of music, let's say you someone like symphonic metal and or something like that, right? And then you also kind of like Taylor Swift, right? So they could be like completely distant, and you're like, what's that, right? Like, well, like what's the next song that I'm gonna show you? We're gonna be whether something that is like very similar to symphonic metal or something very pop. But then you can find somewhere in the middle where like, oh, here's a Swedish band that it's like metal, but it's also like pop, right? So you have like Ghost. So it's kind of in the middle and something that you probably are gonna really like because it kind of tailors to your likeness or taste.
That's really interesting. So if you're looking, I can see how this is maybe useful for research, unless I'm totally off the mark. But if you're looking for two completely different variables and you want, basically Valkey search can help you use those parameters and find all the data that's kind of median in there, which is really cool.
Yeah,
Interesting.
exactly. So, for example, in the case of DevOps, let's say you have an error that is a little bit difficult to debug, right? So, for specifically in the SRE perspective, you can try to find instead of trying to pinpoint an exact problem, you can try to find similarities or similar items that kind of yield the same error, right? So that's
Mm.
a little bit harder to do when you don't know what to look for. And in this case, you have this semantic context that vector search can really help you to kind of narrow down the problem, and then you get that data, and then you go and dive deeper.
Interesting. Yeah. So if you're not sure exactly what the error is, then you can find those two parameters and then it'll find something in the middle so you can get to that answer. And that's kind of related to the next thing that I wanted to ask you about, which is how can Valkey add value to an observability tool stack and make observability easier for DevOps and SREs?
Yeah, observability is usually a problem when you have a vast amount of data, right? So there are certain built-in data structures that Valky provides that allows you to reduce that amount of data and as well as the amount of writes that you're doing, right? So one of the main issues is like you have an application that could have a lot of traffic, and then your observability stack needs to be able to handle that much traffic and more, right? Because you want to keep logs and metrics around it. So one of the really cool data structures is HyperLogLog, which is a mathematical algorithm created by a French person called Philippe Flageolet back in the 80s. So the whole point is that you are able to count items in a very small amount of kilobytes in memory. So with 12 kilobytes, you can store millions and even billions of items with a small percentage of uncertainty. So that means that with about 99% or 99.2% of accuracy, you can say if an element is part of a set or not, right? So that will help you to count like um, the number of errors, the number of 400s, right? Like or specifically like for a force, if it's a client error, etc. So if you have server errors as well, or if you have um, specific things that you want to count and track, that will be really really helpful from an SRE perspective.
Yeah, it's making sense that if Valkey is a database that's kind of meant to handle really large quantities of data and can pick it apart in a unique way that's optimized to be very, very quick, that's a perfect kind of use case for observability when you have like logs, metrics, traces, profiles, all this stuff to quickly be able to deal with that and then help SREs and DevOps professionals kind of find what's going on. So it sounds like it's a perfect kind of data store for that use case.
It is, and there is a few other things. For example, one of the built-in functionalities is something called sorted set, where you can keep a list of unique elements and an associated store to them. So you can have like a leaderboard of your best performing websites, your worst performing pages as well, or services. So that will help you to have a real-time um, view of your stack, right? And of course, you have all those traces and the raw data somewhere else on the data lake. But if you want to have like a dashboard that is really giving you the real-time metrics, It's very different to having something from compared to a data warehouse, for example. And
Interesting.
yeah, one more thing is the ability to do broadcasting. So there's a feature as well called PopSop that allows you to have like real-time alerting pipelines that you can broadcast, right? Like somebody gets pinged when there's like the site is down.
Oh, interesting. Okay. So it's like by broadcast, it sounds like alerting kind of. They get pinged.
Exactly. Yep.
Oh, okay. And real-time data just basically means the data is continuous, where batch processing is like refers to like much older methods where like they would do it in sets, right?
Exactly. Yep.
Okay.
So the the mechanism that is usually used for this real-time processing is the ability for you to have a lot of concurrent writes and you can read that data like immediately, right? So let's say you're making a count. You have a user count or a website count of pages. So you have like the homepage has like 1,518 requests like in the last minute. So doing that in a different disk-based database is going to be a little bit more tricky compared to doing it on an email store. So this is I'm really really excited about how Valkey can help you to have um, this extra functionality on observability platforms, and that's something, for example, that could gets me really excited about like seeing the whole ecosystem and including Valkey as an observability tool.
Yeah, we're always really excited to get to engage with other members of the FOSS community. I have a strong feeling that everyone at Karoot comes from sort of the FOSS background where community and contributing to projects that can help everyone all over the world kind of pursue their projects and innovations and entrepreneurship is really important to the team. So I'm glad that Karoot stood out to you. And with that, I want to segue into sharing some of the experience because, like you said, it's almost 30 years of experience, it sounds like, with management and software engineering and solutions architecture. And then for a while, it looked like you were also managing AI solutions at AWS, which is really cool. So could you share? Let's start with how did you first get introduced to open source at the beginning of your career?
Oh, excellent! So
Yeah.
I can say that mainly the reason behind it is my background, right? So I'm originally from Mexico. So in LATAM, pretty much the technology, we try to keep up with technology from the developed countries, right? But budgets are usually tight. So if there's a word that I could say that brought me into open source is frugality. So the idea is that you can do more with less. That's kind of the root of my open source experience.
Yeah, and I think that's sort of actually in a different way how I was born in Canada, but how I was introduced to it because I started my career kind of doing humanitarian things, and it was like sort of introduced me to me as an international development tool. It's like how can we all succeed when there's a lot of barriers of entry to tech, and if there's tools that everyone can access so they can have their startup and create things all over the world. I think that's a really amazing thing to get to be a part of and contribute to. So I'm glad it helped you in some of your previous roles. What is your favorite part about the open source community and being part of it?
Well, yeah, interacting with other folks with similar mindsets, right? So the whole idea, I think I was introduced to open source probably in the early 2000s when I was in college, and having or having people from all over the world, like you said, right, contributing to the same mindset with a common goal of making software for the world to use. So everybody has different backgrounds and experiences, but we all want to put our little salt into the greater for the greater good.
Yeah, yeah, I really liked how you described that. That's perfect. And from your nearly 30 years of putting salt into the greater good, can you share what your biggest lessons are from working as an engineer that you'd want to share?
Oh, lessons. I would say that keeping things simple is probably one of the main things that I can say, right? Like in that way, I love Valkey because it's the access to the data is very simple, right? Key values. So I would say that doing or learning about a small number of tools, but learn them very well, right? So I think that's something that will help um, um, new folks coming into tech. Learning open source, I would say that's also a cornerstone because those learnings and the knowledge that you acquire is completely horizontal, right? So you can transfer from company X to Y and Z, and everybody will be like, it's kind of the common denominator, as well as working in North America versus Latin versus Europe. Like if we all use similar technologies, you have that flexibility.
Yeah, and I can see that's a great tip is sort of focus in on something specific so you can really excel at it, and then those skills can transfer to different organizations. And going back to technical questions, I really wanted to ask you about tools that you had worked with, your experiences, and I think it was HyperLogLog and Bloom Search, I believe, is the other one. If you want to tell our audience about what those are and how they be used.
Yeah. The old one that you may be referring to is Bloom filters, right? So
Yes,
these are
thank you.
um, two of my favorite probabilistic data structures. And what does probabilistic means, right? It means it's not 100% accurate. So let me start with HyperLogLogs. This is a brilliant data structure. I think I was talking a little bit earlier that answers the question, how many items have I seen, right? For example, if you think about like visitors on a website or errors that you're capturing in your observability tools, the magic is that it can estimate the amount of unique items using a data set that is incredibly memory efficient. So that means that you can store billions of items with only 12K of memory. So that means that you can only you get about 2% or less than 2% of error rate in that fix, right? So you may get probably a little bit higher, right? Like 99.9% of accuracy if you get to a certain amount of elements in the data set. But the whole idea is that you're very efficient as well as super, super fast because it uses certain algorithms to try to hash the data in a way that it turns out certain bits. And yeah, essentially, I would say it's probably really great to find elements on the set. Um, the other one, the Bloom filters, is a little bit more complex. That one you have in your hands, however many elements you want to store and what the error rate that you want to handle. So based on those two factors, you can say, okay, I want to have 1 million items and I want to have less than 0.1% of errors. So that means that he's going to probably use a little bit more bits and he's going to do certain amount of hashes to toggle the bits. So, but this one, it's a little bit different use case. This one will absolutely tell you if you have definitely not seen an item before. So that means that, let's say you want to register into a new website, right? So you want to create a new user, and that username, you can verify if it's not there, right? So if it's not there, it's going to go through. You can also try to see if it's there, and that may be there, right? So you can like, okay, maybe this user is already there, so you're going to have to do a double check with the backend database. So the idea here is that they're completely different use cases. They're very efficient, and I love this because these are especially used in ad tech, gaming, and I foresee that there could be a lot of use cases in observability as well.
Interesting. And so, can you talk more about the use case of the second one? So, when you would be looking to see if a user is there or not there, that'd be like, I might be totally off on the IT side. If you're trying, like, if an account is missing or there's an issue with an account.
Exactly. Yep. So
Okay.
for example, you can say, hey, have this user logged in, right? And like if it's logged in, right? Let's say you keep a set of logged in users. So that means that you can definitely see like if you have a bank, right? Like, do I have a session open? Like maybe you want to restrict that you only want to have one session open. So you can check like, is my user logged in? And then you can go and find on this hyper on the loop filter. And if for certain you're gonna know that the user is not there, right? If you do get like, oh, it is there, that may be in the percentage that you defined that are false positive. That means that you're gonna have to double check, like, okay, I do have a separate flag to say that this is, for example, the token that was given to the user, right? So it would be a second step for extra security. This is where you will make the really quick check, and then you will do a further check later on if we went through.
Interesting. So, it also helps improve things like security. I wanted to ask because you've been working with databases for so long. We talked a little bit about earlier about how Relational databases date all the way back to the 70s, and things like Valkey are much newer technologies. Um, in your experience, can you talk a little bit about maybe big changes that you've seen and how, this is kind of a broad question, but you can answer to whatever pops into mind, how databases have changed and if there are any new technologies that you're really excited about? And they can be new things that are coming out of Valkey too.
Oh, this is super interesting, right? Because if you think about even beyond the 70s, so if you think about when computers started back in the 50s, the actual data store was key value. So
Hmm.
you will store, for example, certain data card, and then you will only be able to see it by the ID, right? And then that went into the 60s when hard disk started to become a thing. It was also the way to organize data, right? So it was a giant dictionary on the disk that you will be able to go, and that's kind of the original kind of data store. And then, like we were saying earlier, back then the hardware was expensive, and then new ways of storing the data and normalizing it came about, and that worked for a long time and still works and will continue to work. I can still foresee relational databases to be used 50 years from now, right? But they have a case. They have a case because they have that flexibility that you don't know what you're going to ask. Whereas on the key value stores, you need to know what you're looking for, right? So it's different mindsets. So they can definitely work together. Um, and new things, I mean, not new, but from the last, I would say 10, 15 years, we're starting to see a lot of data lakes as well. So that
Yeah.
means that's even bigger data sets, right? You're talking about petabytes of data, and maybe sometimes even exabytes. I don't know, but
I've
that's
never heard
a
of that.
really
Wait, sorry, what's an exabyte? I know petabyte. I think petabyte in my brain goes like, what's an exabyte?
well. It's the next zero, right? So then the next three zeros. So let's say you have 1 gigabyte, right? That's common. Your phone has 8 or 16, right? So 1,000 of those is terabyte, right? That's your laptop. And then the next is the petabyte, right? That means 1,000 laptops together that that can store that amount of data. And then imagine, I don't know, that's a room full of laptops. So then the next thing of it will be the exabyte, which is a
Oh,
thousand rooms,
so
right? So a
this is
whole
what, like, I guess most cloud solutions are basically huge server rooms, like an exabyte is basically what they would be using.
yeah,
Okay,
correct.
cool.
Yeah, you think about it like pretty much like a semi truck full
Mhm.
of hard level SSDs, right? Like it's a lot.
It's funny you describe it that way. My board director at my last company was Madog Hall. I don't know if some people in the FOSS community will recognize that name, but he was talking about, I think, at like a DNA project or something where I think because everything was proprietary, they had to literally load trucks full of tapes to move it over to the other lab or something. So, anyways, like you're saying, truckloads and truckloads of this sort of thing.
Yeah,
It's
exactly.
crazy. Go ahead. Sorry.
Yeah. It's like moving a I'm sorry, a data center, right? Let's say you're a bank or one of these health companies. So that like the DNA, that could be a really good use case, right? Because every person generates about 130 megabytes of your DNA sequence,
Oh,
right? So
cool.
let's say you want to have 1 billion people. So that's a lot of megabytes.
Interesting. Okay, cool. So, going back to what
Yep.
we were starting to talk about, though, with this use case, it was, oh, we were talking about things like data lakes. And just to confirm, I'm understanding the difference. I went over this with Josh Lee last time, but it's a data warehouse is if you know how the data is organized, you can put it in a specific way, and then a data lake you can kind of throw it into a pool, and then a data lake house is kind of like a combo of these, right?
Correct.
Okay.
Correct. Yep.
Okay.
Exactly.
Interesting. But like you're
So
saying, so now that we can store all of this data, you're seeing the data lake house is something new that's emerging, which is kind of exciting because of this crazy change in hardware. Like, wasn't it like kilobytes that the US sent a man to the moon on, right? Is always the comparison, right? So
yep.
how quickly things have changed. So,
Exactly. Yep. So going back to your original question, what excites me about? So I'm really excited about this the trend, right? And like I was saying, like it connects back, like Valkey connects back to the early ages of computing. So I still foresee that there's a lot of use cases for in-memory key value stores. In the case of observability, I can definitely see how time series support will enable you to have that real-time metrics, right? So the difficult thing about keeping tabs on what's happening is the rate on how much data is coming in, right? So you funnel in all these traces. So of course that goes to your data lake, right? So your data lake is the raw data, but you want to keep track of, okay, how many 200s I'm getting, how many 201s, right? And how many 400s. And then more importantly, how many 500, what's happening? Like you're keeping tabs of all the API requests that are happening, for example. And then the difficult part is becomes when how do you use compaction, right? Like you need to start to have a mechanism that is keeping compaction to all these traces. I know that I'm having, for example, these average response times, and I want to compact like every minute or every 5 minutes or every hour or every day, right? So you can go back in history and see like, okay, what's the average response time for my endpoint? And you can of course do this. There's many tools already out there, but they do it on disk, right? So the difference with Valkey is that it will be done in memory.
Yeah, I was going to ask that earlier because I think I read that it's an in-memory data store, which is partially, I guess, why it's so much faster, right? On top of
Exactly.
everything else that you described. But so interesting. So yeah, if they wanted to have, and now referencing all that data and very quickly see like, what was, the median and then compare it to whatever the anomaly that they're observing is, they can do that very quickly with Valky, which is really exciting.
Yep, exactly. So just to give you an idea, the fastest NVMe SSDs, right? So the fastest solid state drives are about 50 times lower than accessing memory, right? So that's just physics. Uh, they're getting really good, right? Like every time there's new development in hardware, but it's always going to be faster going to memory, especially having the different levels of memory, right? So you have L1 cache in the processors, and then L2, and then of course RAM.
Interesting. Yeah. And so now I guess basically because it's able to be stored on memory, and correct me if I'm wrong, but memory has also gotten a lot faster in the last few years. It's been a long time since I sold hardware, but it's like we're at, it's like there's like DDR4, DDR5. I'm sure in enterprise level, it's
Yep.
really much even more than that. So I guess that speed allows things to be faster.
Exactly. Yep. So it's the speed and the amount, right? So it also continues to get cheaper. It's still like not every use case is meant to be in memory, right? Like there's a lot of like if you want to store your profile information about your bank, right? That has to be stored on the physical
Mm.
device, right? Because with memory, like the server reboots, the data is gone, right? So you still want to save it on disk, and Valkey does provide a couple of mechanisms to do that. There's an append-only file, and there's also a binary representation that you can have a snapshot of what the data is in memory onto disk.
Interesting. So it's still capable of doing both for when you need those use cases, like in finance, where you actually have to physically store the data.
Correct.
I wanted to ask because you've worked with, I think MongoDB was one, Redis, obviously, Valkey, and MySQL, and a lot of other types of databases throughout your career. What would be your favorite relational database? Because I think you keep making the point that hey, they're both good and valuable just for different use cases, which I think is great to celebrate different tools for different things. So, what would your favorite relational database be?
Postgres, because it's community based, right? It's open source, and it has that flexibility of having lots of modules. One of the first ones that I started to use was Postgres, which is a geospatial indexing capability. Like I said, back in Mexico, I had to work on a project where we had to do some geofencing to keep an eye, like for example, like branding cattle. So you have to like every brand had to be different from all the surrounding areas, right? So that was a really interesting use cases that I had to do kind of computer vision and geofencing with Postgres.
Interesting. Cool. And yeah, another case where open source kind of helped make something possible. Um, I was going to say, so I always kind of like to end with a question about, because I think it always shares kind of a fun, kind of puts the engineer's career in like a fun picturesque story. But what was your favorite software project that you've worked on? It can be personal or professional.
Yeah, well, I actually got to work back in the mid 2010s on a live trivia game. So it was super interesting. Used to work on this marketing company, and we planned to have hundreds of thousands of concurrent players. So it was really exciting to work on this like real time live trivia game where questions will come in and everybody connected at the same time will get the question open up on their phone or browser, and then they will be able to answer. And then, of course, the one who got it right and faster will get the most points, right? So, working with Jitter and this broadcasting that I was talking about earlier, it was super exciting. So, of course, back then we used Redis. I hope they're using Valkey now, this company. So, yeah, that was super exciting and really, really interesting project.
Yeah, no, it sounds like something really fun to get to work on. And imagining like well, everyone kind of participating in that game concurrently would have been an exciting technology to develop. So thank you so much for joining us today, Robert. I really enjoyed getting to learn more about databases and get lots of nuggets from your career. It was really interesting to learn more about tech. Share with our listeners where you're going to be next if you're going to tech events and any cool talks that you're going to give.
Yeah. Oh, well, Alex, thank you. It was great talking to you. I am working on some content, so keep an eye on Valky.io. We'll be going to the Open Source Summit in Europe, in Amsterdam, in the upcoming weeks. I believe it's on the 25th in Amsterdam. And after that, I'm also going to be going to Buenos Aires in Argentina in September. All Things Open in Raleigh in October. So lots
Oh,
of things
okay. We'll
coming
be
up.
there too, so I can say hi. Nice, cool.
Fantastic.
All right. Thanks so much for chatting today. And take care.